Good evening, everybody. Am I audible? I'm going to share my screen. Please let me know if the screen is visible to you. And I hope I'm audible. Alright. Use the chat box in case you need to tell me anything. If you can't hear my voice or see my screen. Okay. So once again, good evening, everybody. Welcome you all to eighth week of live interaction sessions for the course Bioinformatics, Algorithms and Applications. I'm Lavanyayan. I'm a PhD scholar at IIT Madras, and I'll be helping you with solving sample problems for each week's topics between 6 to 8 p.m. on Fridays. So this week we'll be focusing on topic stabilizing residues, thermodynamic database, and stability of proteins upon mutations parts 1 and 2. Let's start with the first question. Name the web server for identifying the stabilizing residues in protein structures. Option A, Roberta. Option B, Fold X. C, CupSat. And D, SRIDE. Take a minute. Thank you, Devangana. I think people are still joining, so we'll wait another minute or so. Thank you, Nagamani. So, as usual, you can use the chat box to type in your answers. Thank you, Hardi, right? Anybody else? 3 votes for D. Hari, okay. Shall we check the answer? So it's option D, which is right. A server for identifying stabilizing residues in proteins. And what are the other three? So option A, Roberta is a protein structure prediction server where The structure is predicted from the amino acid sequence. Right. So in fold X, option B is an empirical force field that was developed for the rapid evaluation of the effect of mutations on stability, folding, and dynamics of proteins and nucleic acid. The question here is identifying the stabilizing residues, okay, which is directly coming from this option. And the last, the option C is CupSat, which is a prediction of protein stability upon point mutation. So it's a web tool to analyze and predict protein stability changes upon point mutations. So as you all said, the answer is D. Question 2. Stabilizing residues are identified using the concepts of A. Hydrophobicity, long range interactions, and conservation. B. Hydrophobicity, hydrogen bonds, and van der Waal interactions. C. Hydrophobicity, conservation, and electrostatic interactions. D. Hydrophobicity, stabilization center, and hydrogen bonds. So, which option is right? Okay, two votes for A. Thank you, Malini and Divangana. Others? Harry also agrees with A. Also Nagaman, right? Okay, so how do we compute or identify stabilizing residues? Four components: surrounding hydrophobicity, long range order, and stabilization center, and finally conservation. Excuse the, since I'll be uploading this directly, I want to write it better. Oops. So identification of is Height of obesity is there in all four. Long range interaction only in A. Conservation in A. Conservation in C. Stabilization in D. So B is absolutely, except for one, there is no other supporting information. A has all three and therefore is the right answer. Question 3. If the flexibility of lysine is 24.2 and asparagine is 19.5 and lysine is mutated to asparagine, what is the change in flexibility? So, how do you measure a change in a property for a mutation? Thank you, Nagamani. Any alternate answers? Okay. Any change in property I of mutant minus wild type? So, what you end with and what you start with. So, this is lysine to asparagine, right? So, you will put in the value for asparagine 19.5 minus 24.2, which is, it will be negative 4.7. So that gives you option A. Question 4. Which among the following is or are correct statements? Option A. Stabilization centers in a protein are clusters of residues involved in long range interactions. Statement B. Two residues are considered to be in long range interaction if they are separated by at least 50 residues in the sequence. And C. The stabilization centers formed between different polypeptide chains can contribute to the stabilization of a protein complex. So, since there are ABCs here, I'm using 1, 2, 3 as options. Okay, one vote for B, or two, I guess, by Nagamani. and vote for 3. I hope you're not disturbed by the noise in the background. I don't know whether you can hear it. There's some construction work going on close by. Okay, Nagamani. Thank you, Malini. Others? So, shall we reveal the answer? Thank you, Hari. It's all the same people again and again. So, why only A and C? Not other options? What's wrong with B? At least 50. That's the problem, right? Stabilization centers in protein are clusters of residues involved in LRI or long range interactions, right? Which is true. Two residues are considered to be in long range if they are separated by at least 50. That's not true. You can have a threshold as low as 12, right? And if a protein of size, say 100 amino acids or 150 amino acids, you're really pushing the limit if you're trying to have a gap of at least 50 residues between two interacting residues, right? And three, the stabilization, and it's not true also, right? So there are residues from different chains separated by some 20-30 residues in sequence, still making contacts and stabilizing the structure as a whole. And option C, the stabilization centers formed between different polypeptide chains can contribute to the stabilization of a protein complex, which is also true. So only A and C and not all of the above, because B is wrong. So all of you are right. Great. Question 5. Methods to predict the stability of proteins upon amino acid substitutions. So what are the options you have? A. Effective potentials. B. Energy calculations. C. Machine learning techniques. And D. All of the above. Thank you, guys. Any other option? So how can you predict the stability of proteins upon amino acid substitutions? So which of these methods can be used? Effective potentials, energy calculations, and machine learning techniques. So all these are useful methods, right? So proteins effective potentials vary when the structure also varies, and you can get some information on the stability of proteins when amino acid substitutions occur. The structure will, if the mutation or substitution is perturbing enough or stabilizing enough, it will modify the structure of the protein, and you can understand its effects by studying the effective potential of the protein, calculating that. Similarly, the free energy calculations can give you an idea of protein stability, and machine learning techniques. So, based on these, when you uh, have data on so many proteins and so many structures being modified when amino acid substitutions occur, you can use machine learning to also predict stability of proteins upon amino acid substitution. So, option D is right. Malini and Nagamani got it right. So, question 6. Which of the following is a web server for discriminating and predicting the protein stability upon mutation? Which of the following is a web server for discriminating and predicting protein stability upon mutation? Thank you, Hari. So we just visited this question. So uh, some of these options. So that in itself is a hint to you all. Thank you, Devangana. Thank you, Nagamani. That's right. Let's see what the other options are. So CubSat, I have pasted the same image, just a different color. So web tool to analyze and predict protein stability changes upon point mutations. And what is the other option? Fold rate, a web server for predicting protein folding rates from primary sequence. The name has it, right? Folding rates. Then IC is an interface structure, evolution, and energy for ISEE, and it's a based energy based machine learning predictor of binding affinity changes upon mutation. So we're talking about protein stability upon mutation and not changes in affinity. Therefore, B is wrong. And option C, Protherm, which you are very familiar. Protherm and ProNit are two thermodynamic databases that contain experimentally determined thermodynamic parameters of protein stability. And ProNit is for nucleic acid interaction. All right. Question 7. Which of the following single mutations is rare in Protherm or Protherm BB? So I'm going to give you 2-3 minutes for this. Please go to the Protham DB website and use that to answer this question. Were you all able to locate? Okay, so let's do this together. I think, so I have, if you want, you could start from, right? So this is what you get. I hope you're all able to see my screen. So you should go into the statistics tab. In here you have pie charts of mutation count based type, single mutation, double, triple, or multiple. And then you have data distribution based on ASA, is it buried or exposed or partially exposed, so on, in which secondary structure it is located in, and how is it distributed amongst organisms. So how is the data distributed in this database? So then based on cell line and so on. So after that you have average stabilizing and destabilizing values. Below that you have mutation frequency count for single mutations. Below that you have substitution matrix for average stabilizing delta delta GH2O and destabilizing delta delta GH2O, and substitution matrix for average stabilizing delta delta G and average destabilizing delta delta G, and then matrix for average stabilizing delta Tm, destabilizing delta Tm. That's it. So what do we need here? We are asked about what's rare. So what should we look at? Frequency, right? So I'm going to note down what the frequency is. I hope this is zoomed in enough for you all to see. Okay, so okay. So what is the frequency between V and L? So this is your, now I think I can write here. So on the left y-axis is your from, and the x-axis is your to. So what do we have first? V to L. So go to L, keep your cursor there, and scroll down until you come to V. So V to L is 112. I'm going to confirm I'm in the right column. Yes, right. So I'm going to put 112 here. Next is L to A. So A is in the front, first ever column. L to A is 496. Here 496. And then W to K. Where is K? K is here. Scrolling down till W, which is 0. Okay. and E to Q. Where's Q? Q is here and E is right here. E to Q is 192. So which is the most popular mutation amongst these four? I'm going to write it as common, and this will be your rare. Correct? So what's your answer? Tryptophan to lysine is a single mutation which is rare in proterm or proterm DD. Was that clear? Okay. So let's go on to, thank you Nagamani. Question 8. Which features are used in a sequence based method for predicting protein stability? Option A, torsion potential. Option B, distance potential. Option C, temperature and pH. And option D, type of mutation and neighboring residues. So think about it. We just discussed about potential, use of potential for, so what was that question on? Predict the stability of proteins upon amino acid substitution. And then here in CupSat, you have uses structural and environment specific atom potential, torsion angle potentials to predict delta delta G in different energy, blah blah blah. Right? Now you have another specific question here. Oops, that says which features are used in sequence based method for predicting protein stability, and have emphasis on sequence based method. I think the answer popped by mistake. Sorry about that. One vote from Malini for D, also from Hari. So in sequence based method, definitely you're not going to use temperature and pH on predicting protein stability. And therefore, when you're talking about sequence, torsion potential, distance potential are also not the obvious answers. But in case you're getting confused by the previously discussed questions or concepts, that's why I went a few slides before to show. So in sequence based method, what do? You look into the, if this is your residue of interest, you go a few residues before and after, you check their effect, right? I don't know where I put down the equation for it, but you have the summation of I to j where it is 2 to 3 residues on either side, right? It was discussed during the lectures, but I believe you all remember, and if two of you have answered right, I think you get the point, right? So the answer is option D, the type of mutation and neighboring residues. Question 9. In exposed coil mutations, which of the following is correct? Inverse relationship between flexibility and stability, inverse relationship between polarity and stability, inverse relationship between hydrophobicity and stability, and direct relationship between hydrophobicity and stability. Nagamani, did you just answer? This is for question 9, right? Okay. Others? Okay. Malini says C. So, what do you guys think? I'm just drawing something random. We're talking about some place like this. It's a coil and it's exposed, right? You won't generally expect such a big coil sticking out, but just for a representation. So, in exposed coil mutation, which of the following is right? So, it was seen that based on the position, so buried mutations had a direct correlation with hydrophobicity. So, this is one of your questions for this assignment, right? So, it was positively correlated hydrophobicity. Why? Because buried residues in the core, they don't like uh, polar solvents or external environment. That's why they collapse and bundle up together to form the internal core of the protein. And therefore, if the hydrophobicity is altered, tampered with, there is a huge change in the stability, right? So, buried mutations are positively correlated with hydrophobicity, whereas coil mutations, the ones that are exposed, they saw a negative correlation with hydrophobicity. So, what does that mean? When hydrophobic uh, residues were increased, the energy was the change in free energy was negative, so which means it is destabilizing. So therefore, it's an inverse relationship. So these three are your options. So amongst those, it's not about flexibility or polarity. It is hydrophobicity. If it were polarity, there should be a positive relationship ideally. But what we know from literature studies is that there's an inverse relationship between hydrophobicity and stability. So Malini is right. Okay, I think I missed a question. So let's move on to current week's assignment. Question 11. If the free energy changes of V12A, V24A, V25A, and V28A mutations are 1.1 kilocal per mole, so Devangana, I think in the first lecture, no, third of this week, so there was an explanation on, or even if you had missed it in the lecture, in general, buried mutations are positively correlated with hydrophobicity, which means those mutations that are in the inside of the protein. Let's say this is a protein. It's a very bad representation. So the residues in the internal core of the protein will be more hydrophobic or apolar. So if those are mutated, I don't know how to put it through. So how do you determine positive and negative correlation? So whenever there is an increase in hydrophobicity and the chance or frequency of mutation or a change to a particular residue increases the hydrophobicity and the change in delta delta G, then you say it is positively correlated, and if it is negative, you call it negatively correlated or inverse relationship. Now, when the internal residues are generally hydrophobic in the core or buried residues, and the ones that are exposed are generally charged or polar residues, right? So now, if in exposed coil mutations, generally, whenever the hydrophobic residues were changed into a polar residue, there was a very big change in the free energy. But in coil residues that were exposed to the solvent or in the outside, whenever or an introduction of hydrophobic residue only changed it, or if hydrophobicity was removed, it the protein will be able to interact even better with the solvent outside. Therefore, its free energy will be minimal and therefore it's more stable. Right? So, hydrophobicity is inversely correlated when it comes to exposed residues. This is for buried. So, we say that in exposed coil mutations, there's an inverse relationship between hydrophobicity and stability. Whereas if it comes with polarity, yes, it will be positively correlated because the more polar it is, if it is in exposed state, more is its stability. Similarly, if it is more flexible, yes, it can wangle, dangle around, and here we are not talking about that. Therefore, it'll and whenever you're talking about flexibility and stability, I don't think they go hand in hand unless if it is too exposed. Again, it cannot be inverse. Whereas this is an option where inverse relationship between hydrophobicity and stability occurs. And option D is true for other cases where the residues are not exposed and are buried amongst other hydrophobic residues. I hope that was clear for Devangana. Okay, let's look at question 11. If the free energy changes of V12A, V24A, V25A, and V28A mutations are 1.1 kcal per mole, 1.1 kcal per mole, minus zero point 0.1 kcal per mole, and zero point 0.3 kcal per mole, what is the free energy change of V35A based on the average assignment method? So, what should you do? Any answers? So for this question, don't overthink so much. Just take an average of all residues and arrive at an average value. So for average assignment method, what do you generally do? All possible or all recorded mutations. So whenever you have data on multiple locations or residues, thank you Priyanka, you take, add and average all of them. So if you see two 1.1s, it's not that you take 1.1 once only and add it with zero point 0.3 and minus zero point 0.1 and divide. No, that's not the way. If there are two 1.1 ones, you will do both because you're taking a weighted average or you're taking into account all the residues or all possibilities that are occurring. If there is more frequency of 1.1, then you will represent it the same way, right? So how should we do this? Just take an average of all four residues. So what will that be? 3 plus 1 plus 1 5 minus zero point 0.1 would be 4, 2.4 kilocal per mole divided by 4. 6 4s are 24.6. So on an average, you are predicting that V35A will have zero point 0.6 kilocal per mole, and that is the free energy change. Okay, so the answer is question 12. In which method the mutants were divided into 380 potential substitutions and the stability of each. Divangana, there's a minus here. Okay, so 1 2 3, 1.1 1.1 will be 2.2 plus zero point 0.3 would be 2.5 minus zero point 0.1 will be 2.4. Yeah. In which method the mutants were divided into 380 potential substitutions and the stability of each mutant was assigned using data from similar types of mutations. Which approach are they talking about? A. Average assignment, B. Energetic approach, C. Distance potential, and D. CubeSat. Thank you, Nagamani. Thank you, Devangana. Thank you, Hari. And there's nothing to discuss beyond this, right? It is, of course, average assignment where you have 20 into 19, 380 mattress, 380 bins actually. That's how you get it. Alright. Question 13. Stabilizing residues are A. Dominated with negative normalized B factors, B. Dominated with positive normalized B factors, C. Almost equally distributed with positive and negative normalized B factors, and stabilizing residues are not related to B factors. Thank you, Vijayanta. Others? Thank you, Hari. I mean, if you have done the assignment and seen the answers, you would know by now. Right, so stabilizing residues are generally in the core, which means they have good hydrophobicity index, and they are in interaction with residues that are far apart, which means they have good long range order. They also have conservation, right? So think about it. So stabilizing residues most often than not are going to be found in the core of the protein, and the word stabilizing means it's going to hold the chains together or hold the structure tight in proper form, correct? So when you have normalized B factor, so if it is greater than 1, what does that mean? If it is less than 1, what does that mean? So when it is greater than 1, it means that the residue is flexible. Less than 1 means it is almost rigid, quite rigid, right? And here you are not saying it's absolutely filled with or only negative normalized B factors are possible, and we are not saying it is completely positive. We're using the word dominated with negative, so they can have slightly positive values. It not always be negative, but dominated with negative normalized B factors seems more probable, right, or more factual, right? So that's your answer. And that's the reason why B is wrong. Almost equally distributed is making it like partially exposed or not as stabilizing as you would describe a stabilizing residue to be. So I'm rejecting C as well. And stabilizing residues are not related to B factor, cannot be, we are not directly correlating it with B factors, but it is an indicator. Okay. Question 14. In a protein, if glutamate in the vicinity of lysine is mutated to valine. Thank you, Vijayanta. What will happen to the stability? So you're talking about E getting in the vicinity of K getting mutated to B. Thank you, Nagamani. So what's going on here? Thank you, Devanana. There's an electrostatic interaction or ion pair between this negatively charged E here and positively charged A here, right? Which is broken when, so it's not about better packing, no, formation of hydrogen bonds, not at all, and there's no formation of ion pairs, but there is definitely, I'm sorry about the noise if it's, I don't know how much is heard. It's, the answer is option D, removal of ion pairs. Should I close some windows or something? Is it, how bad is the noise? The background noise, is it getting cancelled or? Question 15. Which, okay, thanks Nagamani. Which type of residues, actually there are some kids playing around and some construction work going on, so it's too noisy here. Which type of residues is dominant in stabilizing a protein? Aromatic, aliphatic, polar, and charged. Okay. So this is something we had discussed before, not directly, of course, but even with amino acid abundance, we had seen in previous weeks. If you thank you, Priyanka and Vijayanta. One of the early lectures. So this is no direct indicator of the answer, but so on till you had histidine, tryptophan, cysteine being the least present. Right, so aromatic, if you think, what are the aromatic residues? Tyrosine, tryptophan, and phenylalanine. You know what polar residues will be and charged residues will be. So maybe I can write the whole thing. I'm just trying to correlate what we had seen before. LAG. I'm sorry. Now that my pen is a little damaged, it's even more hard to switch. Sidrakpnfq So this was one source of amino acid abundance. Right, so aromatic would be WYF, aliphatic are AVLI. AVLI. So they are in the top six amino acids, right? And followed by, if you include this also into aliphatic. So what is dominant in stabilizing a protein? If you look into aromatic and all, they're somewhere here. So they cannot be the dominant ones. So the number of tyrosine and tryptophan in a protein is going to be generally, these are averaged values, going to be very low. So they don't have any hopes in being the dominant stabilizers. Similarly, polar and charged, of course, they are very important in forming ion pairs for charged, and polar residues have their own role in interacting with the solid molecules. But the major contributors in stabilizing the protein, or which type of residues is dominant, is the aliphatic residues. So I have a research article here it analyzes different proteins from different organisms. They are organisms that live in alkaline environment, acidic environment, halophilic, halophilic, non-acidic, blah blah blah. So relative abundance of 20 amino acids in 22 alkaline, non-alkaline, 14 acidic and non-acidic, 13 halophilic and non-halophilic, 23 thermophilic, 8 cyclophilic, and their homologous mesophyll proteins now. So we ignore this. This is separate SNP actually, and this is the second part that I just cropped. And I don't want to bore you with the entire article. You can always go to the DOI and search. A trend of having a large amount of neutral, non-polar aliphatic amino acids like lysine, alanine, valine, isoleucine, and all protein studied. And the article goes on, right? So this is another justification I brought you here for aliphatic. Question 16. In buried mutations, which property is highly correlated with stability? If you have been at least listening to this session, you'll know the answer. Thank you, Vijayanta and Nagamani. I'm not going to explain this because it's already been done. So, question 17. Which of the following mutations is generally stabilizing in proteins? So, you can either sit and think about it, or I would advise you to use Proterm DB. Okay, Vijayanta says C. Others. And similarly, I'll wait for 1 or 2 minutes. There's no problem. We can take 3 minutes or 4 minutes. I have all the time. And we'll have just hardly another 2 3 questions. So go to Proton DB, find the values corresponding to each. Okay, Vijayanta, will come to that. Priyanka had this is A. But I want you to all, I want all of you to go to the database page where I showed you different tables, right? We just took out the frequency values from one of the tables. Similarly, pick the table appropriate for this question and find out the answer. Thank you, Hari. Did you use the website? Okay, so I'm going to use Proton. So we had used the frequency table. So next, you have average stabilizing delta delta G H2, but I want delta delta G alone and not H2. So stabilizing delta delta G. So what is your question? Which of the following mutations is generally stabilizing in protein? Correct, Vijayanta. So write down the delta delta G values from the stabilizing table. Right. So first is E to M, right? M and come down to E 1.6. Right, 1.6. Second is Y to A, that is 0, which means Y to A will never give you a stabilizing positive delta delta G. Okay, and what is V to H, I to K? V to H means I should keep my cursor in H and go to V. 0. Uh, you will not be expected to remember the table, Vijayanta, so don't worry about it. And I to K is again 0. So the only thing that gives you a positive stabilizing value is option A, E to M. They would generally not ask you questions that require you to remember these many values. So I don't think you need to take pressure, stress over such things. Either you'll be provided with a source of the table, or you might be given with let's say if you need just four values, they might give you k to I or I to k, or k to say A, Y to H, and all those values. So you need to probably pick up without making mistakes on what is the right. You want Y to A and not Y to H or Y to K, and so on, and then you calculate what is the, or A to Y, Y to A. It will differ, right? Even here you see it's not a symmetric matrix. So I to M is zero point 0.9, but M to there's I is 0.55. So it's not the same, right? Changing one residue to the other and the reverse is not the same. So I can give you, the person whoever sets question paper can give you different A to Y and Y to A, and you should know what is from and what is to, and pick the values accordingly and do the sum. So it will be something like that, where you'll be expected to apply a concept, be alert in taking the data, but you will not be hopefully using your memory to remember 380 or such values. Okay. Okay. Question 18. The performance of a computational method for discriminating stabilizing and destabilizing mutations dash when the dataset is classified based on secondary structure and solvent accessibility. Thank you, Vijayanta. Anybody else having different answers or the same answer? Thank you, guys. All of you are right. So it increases the performance of a computational method will definitely increase when the data set is classified based on secondary structure as well as solvent accessibility. It makes it better, right? In a protein, If hydrophobic residues are crowded in the core and alanine is mutated to valine, what will happen to the structure? Option A, enhance packing in hydrophobic environment. Option B, create steric interactions. Option C, no change in structure. Option D, no change in stability. Let me see. Vijayanta says A, Nagamani says B, Priyanka says B. Okay, so why do you have a problem with A and B? Others? No change in structure. Nobody agrees with this. No change in stability. So can we remove? Now first, the word that you're supposed to focus is crowd. In a protein, if hydrophobic residues are crowded in the core and alanine is mutated to valine, so glycine is H, alanine is CH3. So alanine is bigger than, I'm sorry, valine is bigger than alanine, right? So what happens in a tight core where there are so many residues packed, all right? And if in this place or in this place, if this is alanine and this is replaced with valine, which is a little more bigger, what will happen? If it is a little looser, in case you have a little more space, and if alanine had been replaced with valine, then maybe it would have interacted more with other residues and packed better. And option A might have been right, enhanced packing and hydrophobic environment, because you have increased the chain length or aliphatic residue here. But the only problem with option A is crowd. Because the hydrophobic residues are already crowded in the core and now alanine is replaced with valine and it is making a problem where there's already no space to sit, and therefore it causes steric interaction. Are you okay with that? Just going to change the color so I can directly upload this. Here it is getting converted. All right. Question 20. Given the free energy changes of A12B, A24B, A25B, and A28B, mutations are 2.1 kilocal per mole, 1.1 kilocal per mole, zero point 0.7 kilocal per mole, minus 2.2 kilocal per mole, respectively. Thank you, Vijayanta. Find the most tightly packed residue position before mutation. And you know that positive is stabilizing, negative and is destabilizing. Again, you're talking about alanine getting converted to valine. So when these guys are so close by and alanine getting converted to valine, if it is giving you a positive value or stabilizing value, like the case we saw here, where it is fitting beautifully into the gap, okay. Uh, so it can increase. Oops. So what will happen? The delta delta G will be positive and it will be stabilizing, which is the case or which is true for A12V, A24V, and A25V. But what happens in A28V? There is a negative sign, which means it is destabilizing. Destabilizing how? Creates a steric interaction. And why is that? Because they are crowded. So find the most tightly crowded or tightly packed residue position before mutation. So this guy around 28 residue, A28, there was already a crowded environment. So when valine is substituted, you get a negative or destabilizing delta delta G. Therefore your answer is B. Was that convincing, Nagamani? So there's only one option that gives you a negative or destabilizing scenario, and that's because of tightly packed nature before the mutation. All right. So with that, my questions end. In case you want me to repeat something or clarify something else, please let me know. Sure. And you can address me by my name. There's nothing wrong with. I don't expect to be called as ma'am. Mm, so let's see this because I've not polluted the question with writings. Given the free energy changes, so we are essentially looking into delta delta G values, okay, of A12V, A24V, A25V, and A28V. And remember this hint: positive is for stabilizing, negative is for destabilizing. Even in the previous question that you saw, positives were always, for stabilizing delta delta G is always positive. And in another question, we had negative in case of V25A, right? So in general, but I think that was some other property. That was also free energy. Okay. So in general, you can take whenever the change in free energy is positive, it is a stabilizing mutation, and whenever it is negative, it is a destabilizing mutation. In all cases, alanine is replaced with valine. So valine is a bigger amino acid compared to alanine. It's just a schematic. Now let's have it like two blocks. Okay, I think I messed it up more. This is just one. Okay. Now, the given the free energy changes of these residues are 2.1, 1.1, 0.7, and minus 2.2. So what is happening when alanine is replaced with valine? There is a free energy change of so and so kilocalories per mole. Find the most tightly packed residue position before mutation. What does that mean? Before, there is a scenario where there might be multiple amino acids present. And here is your alanine 12. Similarly, you will have alanine 24. I'm just guessing there are so many amino acids, and there's your alanine 25, and you have alanine 28. Okay, I just put random schematics here. This could easily be 12 and that could be 25 also. So in each of these cases there's some gap here, or imagine it is loosely packed, so that alanine being replaced with valine is actually stabilizing the position because it probably is there in the core, right? And the replacement with valine is giving it more stability, where valine is able to interact more, or decrease the distance between residues, so that they are able to have more attractive forces of interaction. Okay, so in these cases you have 2.1, 1.1, 0.7, and minus 2.2 kilocalories per more. So what is the problem with this case? You have a negative value because there is already tight packing, or in this case you have to go the other way around. Why is there negative? Because there is tight packing, or since it is negative, it probably means that valence substituting for alanine has given rise to some problem. So why would that be? Because there's no place. What other difference is there between alanine and valine? It's just a length of the side chain, right? So you can inversely correlate that the most tightly packed residue position before mutation would be alanine 28 rather than 25, 24, or 12, simply because replacement with valine gave a positive free energy change for all other three residues, although the value might vary according to what other contributions were there, but it gave a negative value for A28V. Is that clear for you, Nagamani? Don't go by the magnitude alone. You should look for the positive or negative value. Was I audible? Was this clear? Nagamani, did you understand what I said? Okay, if anybody else has anything more to ask, I think Nagamani has some net issues, or I don't know. So I'm thinking if there is a valve, it will have space to fill. Am I audible, guys? Oh, I think I have a bad connection on my phone. That's why I wasn't able to see the messages. Sorry. In case of delta delta G, Vijayanta, you have to go with positive, meaning um, it is stabilizing, and negative, meaning it is destabilizing. Because you're doing uh, mutant minus wild type. I mean, it's better that I check the chat box here. How to prepare final exam? Any suggestions? I am from zoology background. Whole to think consuming. It's not easy for me. Vijayanta, so there are four TAs for this course, and I am one of the. I don't know about the others, but I think they are from hardcore bioinformatics background. I'm more from biotech, and ideally, I did have some basic bioinformatics, and I'm learning with you all in this course because what I did in my undergraduate study was not very touching, or it wasn't focused on these aspects or databases or data sets that we are dealing with right now. So, how to prepare for final exam? I would advise you to focus on the topics that the lectures were concentrating on, and you can also use the textbook for the course. Um, so, in general, you can learn a lot. I mean, bioinformatics is one course where you cannot restrict. There are developments that are faster, and this course was probably done or recorded in 2016 or 17, I believe. But we are 6 7 years ahead now, and there have been so many other developments as well. So one thing is you will always find more and more sources as you dig deeper into the internet. So if you're focusing on the exam, I would uh, tell you to focus on things that are covered in the course, in the lectures, because in as such as a whole, bioinformatics is vast. But if you're worried about this particular exam, focus on things that these lectures or these textbooks focus on. In general, keep learning. This exam is not the end point, or you will always be finding new things online. Finding there will be uh, tiny nuances in each, even take blast or side blast, unless you use it more for proteins that you're studying, or sequences that gene sequences that you're looking for. You will never feel or get a grasp of the full potential of each resource, or where it lacks, where it is useful. Many a times I've not been able to get any entry out of scope or cat. So then you start reading the tutorials or how to use a particular resource. So the learning keep continuing even after the exam. Always look for more fresh materials. There are so many courses from other universities abroad that are also well, I mean, nice for learning more. But if you're focusing on this exam for NPTEL, go with the course. And where can we get this problem solving session for recalling? Like on YouTube. Oh, is this sheet shared with you or not? I don't know. I can post one of my links. I think I said the same thing 5 6 times regarding the exam preparation, but so if you, I mean, it's up to you whether you want to subscribe to this channel or not, because you'll keep getting notifications. So that might be a little irritating. But you can follow. use one link and go check the channel for any other related content, and I think you should be able to find it. There are four or three other TAs also doing, so feel free to look into their material and their sessions as well. But if you're finding it too overwhelming, you can always just check their PPTs. So along with maybe I can put in that link also. Do this. So apart from, so let me share. I don't know how do you share this. Oops. Let me check this. Yeah. So you have all weeks PPTs, right? Similarly, I think you should have a section here. Bioinformatics, this is 2023, right? Problem solving session. You click on this and you have problem solving session here. When you go here, you have click here to view, right? So week wise, you have Lavanya and Jyotisha, Fatima, Ramakrishna, and it keeps repeating, right? So this is my week 7 lecture. So if you click on this, you go to my PPT, and if you click on somebody else's, you get theirs, right? So even if you don't listen to everybody's lecture, I would advise that you go through their questions. I mean, the content might be repetitive. It's up to you to look into all that. But if there are questions, I mean, there's a lot of recap in this. From here the questions begin. Okay, so there might be different questions than what I have discussed, right? So you can use these questions also to prepare. So you're getting more practice questions than just one. Correct? I understand that it is impossible or very hard to sit for 4 into 2 8 hours of session for 1 week's course, but you always have the option in case you're very interested, or if you're finding 1 week very tough, do look into all the PPTs if you have the time. Okay, so that will help you. Similarly, from Jyotisha, from Ramakrishna, these are readily available links, so use that to get a hold of PPTs. On the left, you have the YouTube links of each video. Okay, so that should cover your question. Anything else? Think which one? This drive thing? Just a minute. Check it now. Now I think anybody will be able to access it. Okay. Anything else? Thank you, Priyanka. So, all right, if there's nothing else left, we'll meet you, and I will meet you on next Friday with week nine's practice questions. All right, have a good weekend then. Thank you all for joining today's session. So, I'm going to end the call. Thank you very much.